Welcome to Ms. Bremser's Wonderful World of Algebra. For the lesson R6, you will be taking your notes by watching the video instead of a live lesson with Mrs. Bremser. As you go through the video, if at any time you want to pause so you have time to write things down or work things out, go ahead and pause the video, and when you're ready, go ahead and unpause it and continue watching. These first two questions are similar to a warm-up just to see what you remember about rational exponents. When you look at this first example, x to the third power, y to the negative second over x to the negative fifth, do you remember that a final answer is not allowed to have negative exponents in it? You did learn this briefly in your Honors Algebra 1-2, but we do need to make sure that we're holding on to these rules. So what I'd like you to do is do questions 1 and number 2, pause the video, and then when you're done, unpause, and let's see how you did. Okay, when you're looking at number 1, if you notice the y's exponent is negative and the x's exponent is negative. Anytime a base has a negative exponent, it does need to change which portion of the fraction, the numerator or the denominator, that it is sitting in. You'll notice x to the third does have a positive exponent, so it gets to stay upstairs in the numerator. The y has a negative exponent, so it needs to go downstairs to become a positive thinker, a positive exponent. Same with the x, it is downstairs in the denominator with a negative exponent, so it does need to move upstairs to become a positive exponent. Once we move it up, you will notice we have two of the same bases, x and x. We are going to then multiply those two together. If you remember from our review lesson number 2, when you have the same base, you simply add the exponents. So we will end up with x to the 8th over y squared. Take a moment if you need to pause and write all that down. Make sure you're comfortable. We will go over the rule in a few slides about why they move from upstairs to downstairs. This was just a chance to see if you remembered. When you look at number 2, I'm hoping you see an exponent outside parentheses. It needs to be distributed to the exponents of all parts of that fraction. That means this becomes a to the 18 halves, which yes, will reduce to 9 in just a moment. B to the negative 12 thirds, yes, we'll reduce it, over C to the negative 18th. Now when I reduce it, we will have A to the 9th, B to the negative 4th, over C to the negative 18th. Now this looks like a problem just like number 1. We have bases B and C that have negative exponents. That means we need to take the reciprocal or the inverse and move them to the other part of the fraction. A is already a positive exponent, so it stays. The B does need to move down to the denominator so that its exponent becomes positive. The C must move upstairs for its exponent to become positive. So take a moment, make sure you're okay with that concept, getting to A to the 9th, C to the 18th, over B to the 4th. We will be using these properties with negative exponents throughout R6. When you're ready, go ahead and move on to the next slide. Here is your statement for today. For R6, our rational exponents. You may want to pause so that you have time to write this in your notes. We have two statements for today. I will use the properties of exponents to simplify expressions with negative and rational exponents. And that's actually where we're going to do part 1 of our notes before I pause to go to part 2. The second part of the notes is going to be I will rewrite expressions with rational exponents in radical form. That means we're going to take something like a to the 3 halves and we're going to write it in radical form. That means the square root of a to the 3rd power. We're going to review that lesson of what the numerator and the denominator mean when you change it to radical form. So now let's look at what some of these rules are. You may want to actually pause and write these rules down. Now, the power rules you should have already written down in previous notes, but if you would like to write them down again just to make sure you're good, feel free. The 3 new ones that I'm focusing on are over here. The product rule, which is if we have a to the r times a to the s, we keep the base a and we simply add the exponents. This is a rule that we have talked about, but we need to make sure we're good. The quotient rule, this is one that might be a little while since you've seen it in Algebra 1. When we are dividing two that are the same base, the a and the a, we simply take their exponents, the r and the s, and we subtract them. So for example, if I had 3 to the 5th power over 3 to the 1st power, that would be 3 to the 4th power, which would be 81 when we simplified it. But we take the 5 minus 1 to get the 4. And then the negative rule is what we were talking about in the warm-up just a few moments ago. If we have a to the negative r, we can rewrite it as 1 over a to the r, which simply means the exponent is now positive. An example for that would be a to the negative 3rd can be rewritten as 1 over a to the 3rd. By changing whether it's in the numerator or denominator, the exponent can change from negative to positive. You might want to quickly write down these rules to make sure you're good. The fourth rule, when you distribute that exponent, you are multiplying now, so it becomes a to the rs. Do not forget this fifth example. When you have an exponent outside, you're distributing it to all the bases. So that's a to the r times b to the r. So both the a and the b receive the exponent. And the sixth one that we do need to remember is when we distribute to a fraction, just like we did earlier, you need to make sure you give it to the numerator and to the denominator. So it becomes a to the r over b to the r. So take a moment, make sure you have those 6 rules down, pause if you need to, and then let's move on when you're ready. Here's where we're going to start making sure we're good. When we have negative exponents, we take the reciprocal to become positive. And remember, take the reciprocal means it can either move from the numerator downstairs, or it could be downstairs in the denominator and we move it up to the numerator. So the example I'd like you to write right here is x to the 4th. X to the negative 4th is equal to 1 over x to the 4th. Now another example that I do want you to write down is we need to watch this one right here. 2 times x to the negative 3rd over 5. Take a moment and visualize that the 2 does have an exponent, even though it's not written. It's 2 to the 1st power, and the 5 also has an exponent to the 1st power. So when you look at this, the only thing that has the negative exponent is the x, so only the x gets moved to the denominator of the fraction. The 2 stayed in the numerator, the 5 stayed in the denominator. Only the x cubed moved for the reciprocal so that it could become a positive exponent. Please make sure you are good with these examples, and then when you're ready, let's move on to the next slide. Let's look at these two and make sure that when we simplify, that we will end up with no negative exponents and only one instance of each variable. And what I mean by that is you'll only have each letter once in your final answer. You're not going to leave a b in the numerator and a b in the denominator. You'll combine like terms. So look at this example right here. You will notice there's a to the 4th in the numerator, but there's no a's in the denominator, and it's positive, so it gets to stay put. The b has a negative exponent, so it cannot stay in the numerator. It must go down to the denominator in order to become a positive exponent. The c has a negative exponent, so it's in the wrong part. We need to move it upstairs to the numerator to become a positive exponent. The d does have an exponent. It's a 1. It's positive, so it stays in the denominator. So only the b and the c needed to actually change places because they both had negative exponents. Look at the next fraction, 2/5 all to the negative 3rd. Make sure you remember that the 2 really has an exponent and so does the 5. So you're going to distribute and multiply the exponent times the exponent. That's going to give us 2 to the negative 3rd over 5 to the negative 3rd. Now before we try and simplify and say 2 to the 3rd is 8, we do need to move them to the correct part of the fraction. The 2 needs to go down in the denominator to become a positive exponent. The 5 needs to go up to the numerator to become a positive exponent. Now we can simplify. 5 to the 3rd is 125, and 2 to the 3rd is 8. So take a moment, make sure you're okay how we distributed, and then took the inverse of both bases because they were both negative, and then we simplified because they were simply numbers, no variables. When you're ready, go ahead and move on. What I would like you to do is take a moment, let's look at this example first, write down the problem, solve it, and then come back and unpause the video and see how you did. Okay, so take a moment and look and see. Did you make it all the way down here where I have in red my final answer? It is x to the 1/4 over 27 y to the 1/3. If you did not, let's take a moment and look and see what happened. We distributed the 3, which became 2 to the 3rd power, times x to the 15/6 power, because numerator times numerator, y to the 6/9. Then I distributed the 3 to the 6, so it's 6 to the 3rd, x to the 9/4, and y to the 3/3. So that's my step in blue. So then I went ahead from blue to green and I simplified. 2 to the 3rd power is 8, and then I reduced my 15/6 to the 5/2. For y to the 6/9, I reduced that to y to the 2/3. On the denominator, I took my 6 to the 3rd power, simplified it as 216, and then I left x to the 9/4 because it could not be reduced, and y to the 3/3 is the same as just y to the 1st, or we could have written it as 3/3 if we'd wanted to. So then, if you look at that, we now have x's in the numerator and the denominator. So we had to take those exponents, the 5/2, and subtract the denominator's exponents, 9/4. So 5/2 minus 9/4, once you find a common denominator, ends up being 1/4. So that's why I have x to the 1/4 right here. Then when I take care of my y's to the 2/3 minus 3/3 over here, that becomes negative 1/3. So that's why I have y to the negative 1/3. That is a negative exponent, so down here in red, we did move it to the denominator. So we end up with x to the 1/4 over 27 y to the 1/3. Take a moment. If you need to make any changes in your notes, please do so. And then I'd like you to write down the next example and see how you can do with this one. Yes, it does have a fractional exponent. Just remember, it's getting distributed to every part of this fraction, but then this exponent is getting distributed to every part of its fraction. Pause the video and come back when you're ready to check your answer. So let's take a moment, look all the way down at the bottom in green boxed in. Did you make it to 36y to the 1/2 over m to the 7/3? This was a pretty involved and tedious question because there were a lot of little steps to make sure we were okay with. Let's go back. We'll start with in yellow. We distribute the 2, that gives us 3 to the 2nd power, m to the 10 over 6th power, over y to the 6/4. That gives us this first fraction. Then we will distribute here and get 8 to the 2/3, y to the 6/3, and m to the 12/3. Now the nice thing is when I go from yellow to red, you'll notice the second fraction reduces nicely. The 6/3 becomes just squared, and then the 12/3 just becomes to the 4th power. Now what's interesting is you'll notice right here, 8 to the 2/3, I have told you that that's a value of 4. That is something that you will see coming up in part 2 of this. If you were to go to your graphing calculator and simply type in x, or 8, and then the up arrow for to the power of, and then do 2/3, you will find that your calculator will tell you that that's 4. Really quick, the reason that is 8 is the base, or the radicand, under the radical sign. The 3 becomes the index, and then we square whatever that answer is. So the third root of 8, the number times itself 3 times to get 8 is 2, and then 2 squared is 4. So that is where this 4 comes from down here. So for now, you're going to trust me on that because it is coming up in just a few slides. So then I'm going to take what I have written in red and I'm going to continue. The first fraction I just reduced. 10/6 is 5/3 and 6/4 is 3/2. Now I'm going to multiply just like normal fractions. I did numerator times numerator. So 9 times 4 is my 36, and then I've got m to the 5/3 times y squared. For my denominator, it's simply m to the 4th times y to the 3/2. I did choose to put the m before the y just so they line up top to bottom, but you could have had them in a different order. Order does not matter with multiplication under the commutative property. So now to go from blue to green is just the simple fractions. We have m to the 5/3 over m to the 4th. So what I had to do in green was m to the 5/3 minus 4. So if I turn 4 into thirds, that's really 12/3. And that gives me negative 7/3. And then I did the same with my y. That's y squared minus y to the 3 halves. Well, 2 minus 1 1/2 is negative half, so that is positive 1/2. That's why it's y to the 1/2 on top. So take a moment, go through, make sure you're comfortable with that problem, rewind or pause if you need, and then when you're ready, go ahead and move on. So let's take a moment and practice this one and see how you're doing. The first one, x to the 1/5, you're going to distribute because it's the coefficient outside. Just remember to think about your rules when you have like bases. So this is x to the 1/5 times x to the 2/3. They are the same base, which means I am going to add my exponents. So yes, we're multiplying, but in the end, when we multiply, we add exponents. Now x times the second term becomes negative 10x to the 1/5 plus 4/3. So the only thing that's going to make this problem tricky or a bit tedious is just finding your common denominators and doing the basic fraction work. So if we make these both to the 15th power, and then find your new numerators, you will end up with 3 and 10. So this becomes x to the 15th power. And then over here, we would change this to have the same exponents of 15 again. And that would become 3 and 20. So it's minus 10x to the 15th power. Okay, did you catch my error that 3 plus 20 is 23, not 17? So here's the question. Are these two like terms, and can we combine them? Or are they not the same as like terms, and we cannot combine them? Take a moment and look. They both are the base 8, but they are two different exponents. So we cannot combine them, so we are done. Yes, they have common denominators, but they are not the same exponent. So take a moment, pause, do the next one. This is going to be just like foiling with your distribution. You're going to multiply those two, and then those two, and then see if there's any exponents with the same that can be combined. When you're ready, unpause and check to see how you did. So how comfortable did you feel with this one? When you distributed, where I have in red, a to the 3 halves times a to the 1/2, that ends up equaling a to the 4 halves. Because they're the same base, we add our exponents, which becomes a to the 4 halves, which we can reduce to a squared, which you'll see all the way down here in red. Then when we did a to the 3 halves times a minus b to the 1/3, that's just minus a 3 over a squared times b to the 1/3. Those are not the same bases. A and b are different, so it simply stays that term, a to the 3 halves, b to the 1/3. It did not change. Then I'm distributing my b to the 2/3, and I get b to the 2/3 times a to the 1/2, which is right here, and then b to the 2/3 minus b to the 1/3, multiplying those two terms, and I multiply those together. Now those are the same bases, b and b, so I can add their exponents. 2/3 plus 1/3 is just 1. So you will notice these are not like terms. This is a to the 3 halves in red, a to the 1/2. They are not like terms. They cannot be added. So as weird as this looks, as a's and b's with fractional exponents, that is as simplified as it can go. So please take a moment, make sure you're okay before you move on. So let's try the next one. X to the negative 7 halves, y to the 1/3, over x to the 3rd, all to the 6th. I would like you to pause, simplify, and then unpause to check your answer. So how did you do on that one? That one was a little bit easier and cleaner to see because there was only one fraction that you had to distribute. Take a moment. I showed my work step by step so that if you made any mistakes, you can look to see where you're at. If you have any questions, look through, see what you can do. When you're ready, we're almost done. We only have 2 more examples. Here's the next one. This isn't just like your foiling and distribution. It's a to the negative 1/2 plus b to the 2/3 all times 2a to the 3 halves minus b to the 1/3. I would like you to work on this one and then unpause the video when you're ready to see how you did. Okay, that is my mistake. We already did that one, so we're on to our last question. Go ahead and write this one down, pause the video, solve it, and then come back and check your work. So take a moment, check your work. 4 over r to the 6th times s to the 8th. How do you think you did? If you have any issues or errors or mistakes, please take a moment. I went step by step by step by changing colors from blue to red to yellow to green to gray to black. So if you found a mistake, go through each step and see if you can find your mistake. You may find that the steps I wrote in blue, you might be able to do some of those steps in your head and just start writing where the red is. That is totally fine, but as far as the video goes, I just wanted you to go ahead and see everything written out so you had a detailed example. That's where I'd like to stop part 1 of your video because we're just over 20 minutes. That'll be for day 1, and you can start on Math Excel, see if you can get started on your R6 assignment. We will pick up with part 2 tomorrow. Thank you. Welcome back. We are now at part 2 of R6 for our notes. Take a moment to write this table down with our exponents to roots rules so that we can learn how to officially take a number that has a fractional exponent and change it into root form. Keep in mind the denominator is the root and the numerator is the power. When you start to see an example, that will make sense. You also want to write down the little shortcuts that if the root is even, there is no solution if the negative is inside the radical. However, if the root is odd, then it can have a negative inside. And you will see how that plays out in just a moment. An example that you might want to write down, just so that you have something to refer to, would be up here that I'm going to put in red. If we have x to the a over b, that can be rewritten 2 ways. Remember, the denominator is the root. It's not always a square root anymore. It could be a square root, cube root, fourth root, fifth root. And then the base stays the base, but the exponent inside becomes the numerator, the a. But you could write the exact same thing slightly different. We still have our radical sign, b is still the root, and the base is still the base, but we could say the whole thing is to the a power. So that is 2 different ways to write the same expression. Just to see that with numbers, let's look at the one we did in our previous slides yesterday. When we had 8 to the 2/3, the base is 8, so it stayed the base 8. The denominator was 3, so the root was 3, but then the numerator 2 was all to the power of 2. That means I needed to know what number times itself 3 times. The cube root of 8 is 2. And when I come back, I can show you how to find the cube root in your calculator. If not, you can research that till I come back. So the cube root of 8 is 2, but now I have that exponent on the outside that I must square. So 2 squared is 4. So that's what we're going to practice right here. Our first example is 125 to the 2/3. Remember, the radical is the radical, but it's the index, the denominator, that tells us the root. So that means a number times itself 3 times. That will equal the base 125. And then whatever that answer is, we're going to go ahead and square it. Well, what number times itself 3 times can equal 125? Well, 5 times 5 is 25, like a quarter, times 5 quarters is 125. So the third root of 125 is 5, but we do have that squared, so the final answer is 25. Yes, once you learn how to put this into your calculator, you absolutely can take care of this. For right now, I do want you to have an understanding of what it looks like when you are doing it by hand. Okay, when we look at the next example, we have 16 to the negative 3/4 power. Notice that is a negative exponent. So before we write it in radical form, we're going to move the 16 as the numerator down to the denominator. It's going to be 1 over 16 to the 3/4. So as we work on this question, the radical sign is actually going to be in the denominator. So we will have 1 over the root. Underneath the root will be the radicand, which is the 16. It is the 4th root, so something times itself 4 times, that equals 16, and then that answer will be taken to the 3rd power. So we will have 1 over, well, the number times itself 4 times that equals 16 is just 2. It has to be a small number if we're multiplying it 4 times and only getting to 16. So that is now 2, but it's to the 3rd power. So we end up with 1 over 8. So take a moment, try that on for size, see how that feels, and then let's move to the next example. We have r to the 5 halves. So we are going to put the 4, that is our base, underneath the radical, that is called the radicand. The denominator is a 2, so it is a square root, and then we're going to take it to the 5th power. Well, that's easy. The square root of 4 is 2. 2 to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So how does that feel? Take a moment, pause, go back to anything you need to look at.
Hi.
Is that for me?
No.
Oh, I don't get the rest.
No. Kenzie, be quiet. Mommy said you have to watch the stinker.
What is one thing worse than a rapist? A child. Look at the sticker. I am freaking out right now. Is Keisha so good?
So how does that look when you check out the final answer? R to the negative 8th is what we divided out as our common factor. If we picture ourselves multiplying, it would need to be times 5r to the squared power minus 10 in order for everything to work. For the second term, this is easy. We have the same numerator and denominator. That cancels. That leaves us with just the 10. That was the easy part. When we had r to the negative 6th over r to the negative 8, I came down here and switched them both so that they were positive exponents. Now I can subtract them, 8 minus 6, which is just 2. You could have also gone along the route of saying negative 6 minus negative 8, and you would have gotten positive 2. So no matter how you look at it, we need to make sure we get that r is to the positive second power. When you feel good... Okay, we're down to our final 2 slides. These next 2 questions are going to blow your mind just a little bit, so let's take a moment and look at the first one. Right here you will see that it is r to the negative 1st plus q to the negative 1st over r to the negative 1st minus q to the negative 1st. They are negative exponents. So the first thing we want to do is rewrite them so that they are not negative exponents. So that becomes 1 over r to the 1st, or just r, plus 1 over q to the 1st, or just q, and that is over 1 over r minus 1 over q. Now the second fraction gets to stay nice and easy because nothing was to the negative exponent. Now hopefully this looks a little familiar from our previous lesson. We have fractions within fractions, so I do need to now take care of that. My common denominator of r, and q is just rq. So I'm going to multiply all 4 parts of the fraction by the new common denominator rq. Now you might be able to just do this mentally and say, I know I don't need the r because it's really not there, it's just the q. So that becomes q plus, the q's cancel, leaving me with r, over, the r's cancel, leaving me with q, minus, the q's cancel, leaving me with r. Now I'm going to multiply that by the second fraction, r minus q over r plus q. Now if we take a moment and look, are there any common binomials that we can cross cancel? Do we have something in the numerator and the denominator? We sure do. Q plus r is the same as r plus q. That is by the commutative property saying that order does not matter. Now look at what we have remaining. We have r minus q, I'm going to go with a capital Q just so we can read it easier, all over q minus r. They look like they're the same, but they're just different signs. Do you remember from last week that if we multiply by a negative 1, we can actually change the signs? That becomes a negative r, and that becomes a positive q. So now, these do in fact match. We have negative r plus q on top, and q minus r on the bottom. That's a positive q and a negative r on top, a positive q and a negative r on the bottom, times the negative 1 we multiplied by. Now they cross cancel, and our answer is simply the negative 1. So take a moment, see how comfortable that makes you feel. Going back to the blue and green, we had to rewrite them as the reciprocals 1 over to get rid of all these negative exponents. Once we did that, we created the fraction that had 4 fractions in it, just like our previous lesson. Good news is the new common denominator was just a monomial r times q. Once we did that, we could cross-cancel the q plus r's, and then the remaining numerator and denominator looked awfully similar, just the signs were different. So we distributed a -1, didn't matter the numerator or the denominator, but I chose the numerator. And in the end, everything canceled except for the -1 we multiplied by. So take a moment. If you need to make any changes to your notes, now's a good time. When you're ready, we'll go with the next question. Do you see this is starting out the same way as the previous one? P to the negative first needs to be rewritten as 1 over P minus, and then Q to the negative first needs to be rewritten as 1 over Q. Now you will notice in our denominator it's also a negative exponent, so we're going to write it as 1 over PQ. Now hopefully we're not getting too nervous because we see the common denominator of all these 3 fractions is a P, a Q, and then a PQ. So the common denominator that we would multiply by all the fractions would be PQ. The P's cross out, leaving us with just Q, minus, and then the Q's cancel, and just our P, over, oh look, the PQ's cancel, and it just becomes over 1. So our final answer is just Q minus P. Looked intimidating and interesting at first, but really, as long as we remembered how to find our common denominator, we ended up being just fine. When you're ready, let's move on to our final slide of the lesson. These are questions that you might want to take a moment to think about, and these just could happen to be on the test. So you might want to take a moment, think about them, write them down, and let's walk through and see what we can do. We have here, if a to the third equals 14, then what is a to the 12th? Well, let's think about that. A number times itself 3 times, that would equal 14. Well, there is no whole number that I can think of times itself that will ever equal 14. So we're going to want to think about this for just a little bit of how we can figure this out a different way. If I have a to the third and I want to know a to the 12th, to me, that sounds like I have a to the third, but I was multiplying it times 4 to be how I got my a to the 12th. So are you comfortable seeing that a to the third equals 14? We want to know what is a to the 12th. Well, the way to get the 12 is take what I had, a to the third, but multiply it to the 4th power. So now let's sub in. What do we know? We know a to the third is 14. So instead of a to the third, I'm going to sub in my 14. But the to the 4th power is still there, and that still equals a to the 12th. So we just found what a to the 12th equals. It equals 14 to the 4th power. Take a moment, let that digest, and then we'll move on to our very last question for the notes. This one says, if the lengths of the sides of a cube are doubled, by what factor will the volume change? This is one, when in doubt, draw it out. If we have a cube and we want to find the volume, in case you forgot, volume is length times width times height. So if we don't know any dimensions, we could just say each dimension is x, and since it's a cube, they're all the same dimension. So the volume would be x times x times x, which is x to the third. So the question is, if the lengths of the sides are doubled, well, double x is 2x. So now what would the volume be if I did 2x times 2x times 2x? Well, that would be 2 times 2 times 2 is 8, and then x times x times x is x to the third. Well, when you look at the original volume, it was x to the third, and in the new doubled lengths and widths, it's still x to the third, but what was the factor in front that it changed by? It changed by a factor of 8. So when in doubt, if this comes up again, you might want to draw a picture with what you know. Draw the cube, label it as x, and find the volume. It would be a number cubed. If we double the sides, that does not mean the volume itself is doubled, because each length is doubled. So that's double times double times double. 2 times 2 times 2 is 8, so it is changed by a factor of 8. You have now officially completed your R6 notes. It is definitely time to make sure that you are working to complete your R6 assignment on Math Excel. Thanks for listening. Have a great afternoon.